There are two aspects that help us to use GBM and derive Black-Scholes equation. First is understanding of Weiner process. The Weiner process, if we change this, the whole pillars that we are standing on would fall. So we need to understand what it is. We say that W naught equal to 0. W has W has independent increment, which means that the last value is not dependent on the first value, and the increment are Gaussian with a mean of 0 and a variance of u, and it's continuous path with probability of 1, and W2 is continuous in time, which means that all of these disturbance that are going to shock and create that random part or undeterministic part or noise in our signal is it's normally distributed with a mean of 0 and variance of u and all these small things. But it is also dependent on time, so if it's a long time, then maybe that the thing would get scaled up. So this is how we start thinking, and the derivation of root t scaling of time comes also from here. So that is one way to look at that. Okay, now the other derivation that I have is of Ito Lema. We would use this in the derivation of Black-Scholes. The whole lemma starts with this. We have a small change in a stock price, and we say that it is driven by a return that has been happening over time, and it is also dependent on a shock or a disturbance that we know is going to hit the stock. Now if we use this and expand this thing, so we can write a new function. Now this new function is actually a function of x and t. Now we were trying to find out the change in x, but now we are looking at a new function, and we want to find out the change in this function based on change in x and change in t. So when we start looking at that, we write that any function, new function that is dependent on x and t would follow this equation, where it would say that df by dt dt plus df by n, and so on. And if you substitute xt for x and mu t dt for dx, because we know that change is going to be that small, we get this long equation where df by dt plus mu df by, and we have Weiner process at the end. So till this time we did not get rid of the Weiner process. It's still sticking on the right, but what we got, what we will have the power to use this is get rid of this equation if we can get something on the left hand side. So coming back to what we were trying to do, we said that if we have this equation, which is this, and this comes from Ito Lema as we saw it, and we understand what dW is, and we create a delta H portfolio where we say that the value of our portfolio is dependent on the price and the change in price, and the small change in our portfolio is equal to the change in portfolio and this, and then we have and then when we look at that, that we have this is from Ito's lemma, and then we create a new portfolio, a new function of our liking, because we want to find out the payoff of a call option or a put option, and then we write that in terms of dv by dt. So we got this one, this is dt, and we have dv by ds delta s, and then we substitute the same thing in the expression 2. So we want to substitute, we have dv by ds, so we want to substitute this equation, the second one, and when we do that, we will find out that that term vanishes. In other words, if you see closely at this equation, this second one, if you divide by dt, you take a differentiation of t from both sides, and then you have half sigma square s square dv by ds square delta t. So we are trying to substitute this whole equation, and when we do that, we will have two equations. One is the equation that was left over by this, and one is the equation that was left over by the other part, and then we can solve it. So the whole idea evolves here, because if you see delta S, this is the change in stock price, and this delta V, and when we have both of this delta S and delta V, we can put this delta V on the top here, and we can put delta S on the top here, and since both of them have the same Weiner process kind of a term, both of them would get cancelled because one is of a negative sign and one is of positive sign. But this will only happen when you want to find out the call and put price. You cannot solve. So the new function that we created 2 is only for a call option. If you want to solve this beyond a way in which you don't want to solve for a call option, then maybe the solution would look different. So once you have delta S and delta V, the idea that you can create a new function that is dependent on both of them, here you created 2, and then you can just bring both of them and put them, and then you will get rid of the Weiner process and you will get a final very good equation. And this is a kind of a heat equation, and from here things are fairly easier once you get rid of the dW, which you don't know how to integrate. So in a way you got rid of what you were not able to integrate in the normal calculus.